Hello everyone, and welcome back to our class in Artificial Intelligence and Machine Learning in Finance. In the last videos we've seen classification trees, and we now want to use basically the same model for a different purpose, for regression analysis. So we'll continue our application, but we now need a different data set. We again use a dataset from Kaggle, but this time it's one that is on insurance premia. You can download the data here under this link, and we want to predict insurance premia, which are expenses for customers and potential policyholders. And we have data on close to 1,300 health insurance policies, and we have 4 numeric features: age, BMI, number of children and expenses, and 3 nominal features: sex, smoker, region. So obviously we want to forecast the expenses, the insurance premium, and we are going to use age, BMI, number of children, sex, gender, smoker, yes, no, region, yes, not yes, no, but the different regions to predict the insurance premium. We need to import the data, so we use the readr library. We download the CSV file, import this. There seems to be a duplicate entry, so actually we need to remove the duplicate entry. If we now use sum is.na insurance, we get 0, so there are no missing values, which is important in this context. And we have a look at the insurance premium to get a summary. As you can see, the mean is $13,000 probably dollars. The maximum is $63,000, and the minimum is $1,122. So that's the data. We use the Tibble library. We convert the data into a Tibble, and we print the first 8 observations, and you can see we have female, male, 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 female, 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 the body mass index, number of children, smoker, yes, no, and the regions and the different expenses. Now we create the training and test data, which by now is pretty standard. Again, you can see the 80% of the observations go into the training data, 20% in the test data, X-train, Y-train, X-test, Y-test as a standard, and as it has been done before a number of times. Again, we use the caret package. We set train control, the option to cross-validation, tenfold. We set seed in line 3, and as single trees are fitted very fast, we do not need parallel computing here, and we actually consider various hyperparameters, so the length of our tuning step is 100. The metric needs to be different now. We cannot use accuracy, which is for classification, but this is a regression tree. Y-train is now a metric variable, so the function sees that even using rpart, regression partitioning, it sees that this is not a classification but a regression task, and the metric then is the relative mean squared error. That cannot be accuracy as before. And then we print the complexity parameter 0.0061, and this is what happens. You can see now with increasing complexity parameter, the RMSE increases. It stays constant sometime, and then it jumps up. Now, to visualize the optimal tree for the optimal complexity parameter, you can see here that on the first level, it's quite interesting to see smoker, yes or no. Actually, what you can see here, these are the expenses, the insurance premium, and as you can see, if you're a no smoker, you're immediately in this area where actually the premium are relatively low. Then if you're young, it's the lowest premium. If you're old, and then it's a question if you're not as old or if you're rather old, then this is a distinction made here. If you're a smoker, And if you have a high body mass index and if you're old, then 5% of the observations have a very high insurance premium. Now, what is the predictive accuracy here? Again, we predict based on the test data sample, and you can see the R² is 87%. The root mean squared error is 4,238, and the mean absolute error is 2,900. Obviously, the R² is easiest to interpret, and we get that in this model, close to 87% of the variance can be explained by this regression tree. We could also use boosted regression trees. However, XGBoost only works with numerical features. And as we've seen, actually smoker, yes or no, a categorical feature, binary variable, should be included because it seems to be the feature that has the highest predictive power. If we leave this out, this would lead to an inferior model. We can do this, but you can see the R² immediately drops to 9%. Instead, if you rely on bagging via the method treebag, and if you use all features, this does not, in this scenario, lead to an improved performance compared to the single tree model. The R² drops to 81%, but it's a good thing to try this out. Okay, so this is a regression tree. Classification, regression can be done by trees. We've seen few examples and some nice applications. And in the next video, in the next subsection, we will start with using and discussing a huge part in artificial intelligence, which are neural networks.